This video is about calculating mechanical power. So here I've got a motor that the catalogue tells me is supposed to travel at 100 revs per minute. I'm going to use it to attach a wheel to. The wheel has a radius of 0.3 meters, and I'm going to use it to try and move a small buggy along a surface. The road resistance will cause 100 newtons of force at the outside of the wheel. So what we're going to try and do is calculate the power required by the motor to start my buggy moving. I know I haven't drawn the whole buggy, but you get the idea that that motor would help drive that wheel. So the first thing we're going to have to do is calculate the torque produced by this diameter of wheel or radius of wheel. So torque is equal to force times radius. Torque therefore is 100 newtons times the radius of 0.3. Torque therefore would be 30 Newton meters. So that's the torque at the outside of the wheel. Now if we work back from the outside of the wheel, back to the shaft, back to the motor, then what we should be able to do is we should be able to work out the power. So in your data booklets you have a formula of power is equal to 2 pi nt. Now just explain this for a minute. You'll know what 2 is and you'll know what pi is. N is the number of turns. Now we'll come back to that in a wee minute, and T is torque. The number of turns needs to be in seconds. That's because the unit of power, which is watts, now the unit of power, which is watts, can also be expressed as joules per second. So the fact that that's in joules per second, which is watts, means that the number of turns also needs to be in seconds as well. So up here, 100 revs per minute, divide that by 60, that will give me an answer of 1.66 revs per second. I can then go on and calculate the mechanical power. So power is equal to 2 times pi times n, which is the 1.66, times the torque, which I worked over here, which was 30. And if I type that into my calculator, that gives me an answer of 312.9 watts. That's the mechanical power required by the motor to start this wheel moving against the road resistance. This next video is going to look at the efficiency of the motor. So in this past question we calculated the power required by the motor to start the wheel moving. Now going to have a look at the efficiency of the motor. So efficiency is calculated by power out divided by power in. So that symbol there, which is eta, the Greek symbol, power out divided by power in. So in this particular example, the power in is going to be the electrical power. So if I had, for example, a 240 volt supply and that was drawing 4 amps of electricity, so we've got the voltage and we've got the current, then the power in can be calculated by P is equal to I times V. The current 4 times 240, kind of deliberately chosen some nice easy numbers. The input power would be 960 watts. Now from the previous question we found out that the power out was 312.9 watts, so then it's just a case of putting that into our formula. Power out is 312.9 over 960, which gives me an efficiency of 32.59%. Okay, so efficiency is usually expressed as a percentage. So 312 divided by 960 gives you 0.32, which when you multiply it by 100 gives you the efficiency.